Okay, so we're going to practice with quadratics. You have a chart all filled out. On the top of your chart it says general form, vertex form, and intercept form, and then it has some information about it. So the first thing I want to refresh your memory on is graphing. So let's say that we had an equation and it was in vertex form. So that's of the form a parenthesis x minus h parenthesis squared. So this whole quantity is squared, and then you have plus k, and there's a constant at the end. So let's say, for example, I was given f of x equals x minus 3 squared minus 1. So when I have an equation like this, I need to know what my a value is to tell me if it's going to open up or down. So I know this is a quadratic because my degree is 2. And then I look in front of this group that's being squared, and there's no number there. So if you don't see anything, then that means it's a leading coefficient of 1. So my a value is 1, and it's positive 1. If it's a positive 1, that means the parabola is going to open up. If it's a negative 1, that means the parabola is going to open down. So a equals 1 means it's going to open up. I think it's easiest for me to graph from vertex form because automatically I know what the vertex is. So the vertex, you take the opposite of the sign of the number in here. So your vertex is hk. Vertex is hk. So here it's not negative 3, it's positive 3. And then k, you keep that sign exactly, negative 1. So if I wanted to graph this function f of x equals the quantity of x minus 3 squared minus 1, then the first thing I would do is I would plot the vertex at 3, 1, 2, 3, negative 1. And I know that it opens up. So there's a couple of ways to graph. One is to find a couple of points. So what you could do is you could find your y-intercept. If you are a y-intercept, you're on the y-axis. If you're on the y-axis, that means any points are going to have an x value of 0. So if I wanted to calculate my y-intercept, I would just evaluate f of x by plugging 0 in for x. So that would be 0 minus 3 squared minus 1, which equals 9 minus 1. Remember, you're going to get negative 3, but negative 3 squared is going to give you a positive 9, and this is 8. So my y-intercept is going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8. Also, you could use your parent functions. So we have our parent table for quadratics, and we used negative 2, negative 1, 0, 1, 2, and we knew that was 4, 1, 0, 1, 4. Now, my a value is 1, which means there's no vertical dilation, so that means I don't have to multiply anything. And my a value is 1, so I don't have to change signs of anything. So this parabola is going to behave like my parent function because there's no dilations, and my vertex is going to be at 3, negative 1. So from 3, negative 1, this is my vertex was usually at 0, 0. It's going to behave the same. So I could go to the right 1 and up 1, and I can go to the left 1 and up 1. Then I can go to the right 2 and up 4. 2, 3, 4. Over 2, up 1, 2, 3, 4. And then I could even go over 3 and up 9. And from here, if I go over 3, I'm at the y-axis, and if I go up 9 from negative 1, I'm at my y value equals 8, which I already found to be 0, 8. So it worked out where I could follow my parent table, or I could find the y-intercept and graph from there. So you can only use your parent table exactly how it is for your driving directions if your a value is 1. If it was negative 1 or a different number in front, then you'd have to multiply your y value. So this is vertex form. I found the vertex, I plotted that, and then I found my y-intercept as a way to check. You don't have to do it unless on the quiz it says, what is the y-intercept? In order to calculate it, you would plug in 0, and you'd know that your y-intercept was at 0, and in this case, 8.